Okay, if you have not done so already, you have a Mastery Check 1 that needs to be complete. It will be Mastery Check number 1, covalent bonds in quizzes. So if you haven't done that, I suggest you do that first before you get covalent bonds and metallic bonds confused for your quiz. Remember, when you log in to take your quiz, you have, or your Mastery Check, you can take it once and write down all the answers that you got incorrect and then go back and take it again. And if you have any questions or can't get logged in, please send me a message in the chat, Teams chat. All right, metallic bonds. So unsurprisingly, metallic bonds are bonds with metals, right? So metal atoms are arranged in a very compact and orderly pattern. They do not share, gain, or lose electrons. The outer energy levels of the metal atoms just overlap. So instead of sharing or giving up or gaining electrons, they're just kind of overlapping their orbitals. The metal atoms in a metallic solid contribute to their valence electrons to form like a sea of electrons. So you get a whole bunch of metal atoms together, and then they're just like sort of electrons in this, like a sea full of electrons with the nucleuses just kind of floating about in the sea. The electrons are not held at any certain atom. They move freely around from one atom to the next. These electrons are referred to as delocalized electrons. So that's a good vocabulary word, delocalized. That means that they don't share. So when you share, you have to kind of remain in one place in order to share. And then we'll see ionic bonds donate electrons or accept electrons. So these are different. They're going to kind of overlap their orbitals, and then it's just going to be electrons everywhere. And they don't have a specific bond location, whereas we showed you exactly where those covalent bonds were going to end up in the last one. We showed that how those two electrons were sharing with those little lines. When the valence electrons leave to join the sea of electrons, it leaves behind a metallic cation. So the atom itself has a slightly positive charge. And I will say this probably 10,000 times. When you lose an electron, you become more positive. So think about when you ditch someone who's super negative in your life, you become more positive. This bond is an attraction of this metallic cation for these random floating around electrons, because electrons are negative and now the metal atom is positive, and opposites attract. So the positive metal ion is going to be attracted to this random sea of electrons. And so that's how the bond actually happens. So what you see here is all these little dots are just delocalized electrons, and they've all left. These electrons are just swimming around in here, and they all left these metals, which are right here, and these metals became positive, and so now they're sort of attracted. And you see how this is a very orderly pattern. Okay, that's what makes metals so sturdy, is this orderly pattern when they are doing metallic bonding. So characteristics of metallic bonds: they are genuinely solid at room temperature. They're malleable. That means you can shape them into different shapes, like you can bend them. They're ductile, which means they're able to bend without breaking. So they're not brittle, they're pliable. Think like Gumby, like you can bend them really easily. They're durable. They have a pretty high boiling point, which means it takes a lot of energy to boil. The melting points vary, but it's generally in the middle. So an alloy is another vocabulary word. What are alloys? They're a mixture of different metallic elements. Okay, so the elements on the periodic table that are metals can bond in different ways to create alloys. The properties of the alloys are often superior to the properties of the individual, right? And so they increase the uses of metals. When you can combine different metals in different ways, you can actually make things that are stronger and better than if you just use the metal by itself. So steel, anything that's steel, brass, or pewter, these are all examples of metals that have been combined together to form something better than their original part. So there are two types: a substitution and an interstitial I don't necessarily care that you know the difference. I care that you know that there are two types. So this is based on how the elements form the alloy. So a substitution alloy is atoms of the original metal are replaced by atoms of a similar size of another metal. So we're just like, if this was all metal, this was all one type of metal, the dark gray circles, and then I just took out a dark gray circle and substituted a green circle. Okay, that being a different type of metal element. Then that is how this particular alloy is made. An interstitial alloy is basically the different metal, so you keep your all gray circles, but the new metal that you're mixing together is going to go in the spaces between the metal. But see how organized this is, though? This is very characteristic of a metal. All of these atoms are going to line up in a very organized way.